Hello there. In the past few videos, we have talked about three different methods for conducting a hypothesis test on the population mean mu. In this video, I'm going to summarize all three with one concise example to sort of summarize all the processes and then compare the, equivalent results of each of the three methods. All right, so let's get started. Let's consider the following problem that the amount of water that people drink in any given day is normally distributed. Let us assume we don't know the mean and we don't know the standard deviation of that distribution. Let us assume that your friend claims that everyone drinks on average 3.2 cups a day. Conduct a statistical test with a level of confidence 95%. Alright, so with that information, it's given that the null hypothesis is going to be 3.2 cups. Let us assume that we have no evidence that it's more or less, so we're going to choose the easier alternative hypothesis, HA. Mu does not equal to 3.2 cups. Alright, we're going to operate under a level of confidence of 95%. That's going to force our statistical level to be 0.05. Alright, so let us collect a sample. So collect a sample. And let us assume that we get a sample S that has the following characteristics. Let us assume the sample mean is equal to 3.57, the standard deviation is equal to 0.58, and the sample size that gave us that was 19. So a couple observations here. The null hypothesis is 3.2, the sample mean is 3.57. They're not so far away, so this could go either way, reject or fail to reject, depending on a couple things. But of course the standard deviation is not known and the sample size is relatively small. So we're going to use a t value for everything. So let us draw our most common picture associated with these types of problems. So there's some level of confidence that is symmetrically distributed around this distribution. And we've already decided that we're going to use a t-distribution with new degrees of freedom. So we're going to begin by looking for these critical values, t alpha over 2 and minus t alpha over 2. Alright, so with this picture, where this area is equal to c, we know that the integral from minus t alpha over 2 to t alpha over 2 under the t distribution dx is going to be equal to this level of confidence of 0.95. And here nu is equal to 19 minus 1, which is equal to 18. So this is the amount of degrees of freedom for this t distribution. So if you were to solve this equation out, you're going to get a critical value of t alpha of 2 is equal to 2.101. So this is an important piece of information. So from here we can calculate our marginal error, which is t alpha over 2 times s divided by the square root of n, which is going to be equal to, once you plug everything in, 2.101 multiplied by 0.058 divided by the square root of 19. Misprint, there's no 0 there, so 0.58. And that's going to be approximately equal to 0.28. So that is the marginal error. So that also is a useful piece of information. All right, so let's conduct our hypothesis tests. All right, so method 1, let's construct our confidence interval. So our 95% confidence interval for the population mean is going to be equal to x bar minus the marginal error and x bar plus the marginal error. So that's going to be equal to 3.57 minus 0.28 and 3.57 plus 0.28. So that's going to come out to 3.29 comma 3.84. So this is my confidence interval for my population mean under a level of confidence of 95%. Alright, so that is one approach, and we'll conclude the hypothesis test in a second. So the next thing we're going to calculate is our test statistic. So that's going to be equal to, again, the square root of n times x bar minus mu 0 divided by the standard deviation of the sample. So that's going to be equal to the square root of 19 times the sample mean, 3.57 minus the hypothesized mean, 3.2, over the standard deviation of the sample, 0.58. So we're going to get that the test statistic for t is going to be approximately equal to 2.78. And we'll conclude some things about that in just one moment. And the last thing that we will want to calculate is going to be the p-value. So recall what the p-value is. So we have this test statistic here of 2.78 and its opposite. So the p-value is going to be the area that is associated to that test statistic or something better. And keep in mind this distribution is a t-distribution. So that means the p-value is going to be equal to the integral from minus infinity to minus 2.78 of t of x dx plus the integral from 2.78 to infinity of the t-distribution. And that is going to come out to 0.012. So these are the three things that you need to conduct a hypothesis test for a population mean. So now let us go through each of these three and conclude each of them one by one. All right, so starting with the confidence interval approach, recall that the null hypothesis mean is equal to 3.2. So if we look at this confidence interval, 3.2 is not in between 3.29 and 3.84. So since mu0 does not belong to my confidence interval, what do? Then that means we're going to reject the null hypothesis. But of course you should take note that 3.2 and 3.29 are not that close. They're pretty close to each other, so we are rejecting the null hypothesis, but it's not strongly. We can sort of see that, but some people may think that that is a strong difference. All right, so now let us look at the test statistic value. So recall that the critical value t alpha over 2 is equal to 2.101, and this is what we use to calculate the confidence interval. So since the test statistic is bigger than the critical value t alpha over 2, then we're going to do what? That means we're going to reject the null hypothesis. But again, if you look at 2.78 and 2.101, then yes, they are close. So even though we are rejecting the null hypothesis, it's not really a strong rejection. So notice that this confidence interval approach and this test statistic approach are giving pretty much the same exact conclusions and interpretations. So this is our p-value approach. So recall that since the level of confidence for this is equal to 0.95, 0.950. And that means this level of alpha is equal to 0.050. So I'm going to compare these two values, and what do I see? Well, which is smaller here? So the p-value is smaller than the alpha value of 0.05. Remember, we want p-value to be low and we want t-stat to be large. So large test statistic, small p-value. So since the p-value is less than our level of statistical significance, then we're going to reject the null hypothesis. But again, look at the difference here. It's only difference by, about what, 4% difference here? Less than that, so it's like 3.8%. So one may think that's large, one may think that's small. But in either case, one may say that this is we are not strongly rejecting the null hypothesis, but nonetheless we are rejecting it. So that's pretty much how to conduct a hypothesis test mean. So pretty much we have a hypothesis test for the population mean, and you can approach this one of three ways. You can approach it with confidence intervals, you could approach it with test statistics, or you could approach it with p-values. It doesn't really matter which one you use, but usually this is intuitive to those who are not statistically inclined. So if you're given a presentation, confidence intervals are usually the best way to go. If you're looking for something quick, definitely test statistics is the best way. But if you just want another way to sort of verify your work, p-values is a commonly used method as well. But overall, all these three methods are equivalent in their conclusions. So don't think that you're going to get different conclusions like reject for one or fail to reject for the other. As long as you don't change any values for your samples or your level of confidence or anything, all of them are going to give them the same result. And that's pretty much how you conduct hypothesis tests for the population mean and the three methods that you can use to do it.